Lesson 12.5 deals with angle relationships in geometry. Theorem 12.5.1 connects arc measures and the measures of tangent secant angles with tangent chord angles. Theorem 12.5.1 says if a tangent and a secant or chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. So here we have tangent BC intersecting chord BA, or if I extended BA and made it a line, it'd be secant BA, but on the circle at this point of tangency. Then that means the measure of angle ABC is half of the arc it intercepts, which is arc AB. The angle is half the arc. Now, this is very consistent with what we had last lesson when we had two chords intersecting on the circle. Again, the angle was half of the intercepted arc. So what we can see from theorem 12.5.1 is it doesn't matter if it's two chords like last lesson or a tangent and a secant or chord. The angle is still half the measure of the intercepted arc. Now, what if they don't intercept on the circle? This one, notice these two angles intersect inside the circle. It says if two secants or chords intersect in the interior of a circle, then the measure that each angle formed is half the sum of the measure of its intercepted arcs. That is, measure of angle 1 is half of the sum of the arc it intercepts, AB, and the arc its vertical angle intercepts, CD. So 1 is half of AB plus CD. And theorem 12.5.3 says if a tangent and a secant, or two tangents, or even two secants intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measure of its intercepted arcs. So in this case, we've got a tangent, CD, intercepting a secant, CA. In this case, we have a tangent, FE, and a tangent, FG. In this case, we have a secant, LJ, and a secant, MN. But regardless of it, you'll notice there are two arcs that get intercepted here. There's a big arc. In this case, the big arc is AD. In this case, the big arc is EHG. And in this case, the big arc is JN. And that's always going to be the one farthest away from the vertex point. Intercepting in a small arc that gets intercepted, here we can see the small arc is BD. Here we can see the small arc is EG. Here we can see the small arc is KM. So in all these formulas, the angle 1, angle 2, angle 3's measure is half of the difference, that's subtraction, between the big arc, red one, AD, EHG, and JN, subtract the small arc, green one, BD, EG, and KM. So it doesn't really matter if these are tangents intersecting or secants or one of each. The measure of the intercepted angle, or the angle, is half the big arc it intercepts minus the small arc that it intercepts. And throwing it together with what we have up here and what we learned in the other lesson really boils down to three things. Does it intercept on the circle? If it does, then the angle is half the arc. Okay, so we look here, on the circle, half the arc, on the circle, half the arc. Does it intercept inside the circle? intersect inside the circle, and then the angle is half the sum. There's really only one way that can happen, and that's with two chords. Half the sum. Or does it intersect outside the circle? Here we have a tangent and a secant intersecting outside, two tangents intersecting outside, two tangents or two secants intersecting outside. So if your lines or segments intersect outside the circle, then the angle is half the positive difference. And it's positive difference because we need to make sure this angle is a positive measure. How do I make sure it's the positive difference? I just take the big one minus the little one.